In this demonstration, I would like to show you what does it mean to change or adjust the so-called join offset of a servo. Okay, so the servo here is made into like a little gripper, and its ID is 20. So if you want to do this one, you need to create a gripper, and also make sure you check on it. So I'm having the manager tool up here, and I'm just using a girl walk over here just so I can have a controller. The rest of the girl walk is not related to this example at all. This is 20. So if you COM3 here, you check. You see it have 1 through 7 for the girl walk itself. It's all have 20 for the gripper here. Okay. So disconnect that. It's also using a motion file called the basic gripper.mpn file. So let's connect it and then see what these pages are supposed to do. That's the way it's going to connect. So page 1 is to close grip. So you play it. That's a closing position. Open is page 2. So one with that. And then neutral position is good old 512, so it's somewhere in between. Okay. So the join offset, you read the book, the join offset only work if you activate a motion page. It's only work in conjunction with motion page. It does not work with the goal position command. Okay. So that means in order to get an offset working here, we always had to call the page, whatever page you want to. Essentially, I'm going to play the page of close grip in my task program. All right. So that's where they are. Let's disconnect that. So I can have the COM3 port again. Let me minimize in case we get back in. So this is the X12 Join Offset program. So what does it do? So the parameter 20 ID set that equal to 20. You have a parameter called grip speed called 200. That's the speed of the servo essentially. So first, as usual, we need to adjust the counterclockwise, which is address 27 here in margin, counterclockwise margin address 27. The clockwise margin is at 26, and the punch is at address 48. So like before, the margin of the punch, you can do a custom command. So, okay, so you can have a variable called ID here for it. So basically the margin is set to 1, so we wanted to go real precise, and the punch is set up about 16. Next, we're going to set up the torque limit, and that kind of equivalent as far as the gripper goes, like the gripping power, shall we say. How much current do I allow to send into the servo, so torque limit. So that equivalent power. And then the so-called softness is, does it squeeze on you real fast or does it squeeze you gently? I call that the softness, and that's the slope, which is after 28 and 29. So I set up 32. Usually that's the standard for position control. So it's the same parameter, torque limit and slope, but have a different meaning when you have design a little gripper like that. So first, I initialize a parameter called adjustment to 0. And then I say, oh, address 20 join offset, set it to 0. That means there's no join offset. Okay. And you notice these things I use custom command, but the way it turned out is both people do not allow us to do a custom command on join offset. So it had to be exactly a constant ID. They used to be able to let us do the ID, but they won't let us do it. Okay. and then I display motion index, okay, which is basically closing the gripper. Okay, so you can see the model, when the program runs, it's going to close the gripper first, and just wait there until it's done. Nothing special there. And then it start going to the endless loop. Endless loop will say, oh, go ahead and go to motion page 3, which, if you remember, 3 is a neutral pose. And then wait until it do that. So it's gonna close and open the midway, and then it start doing the rest of the endless loop. It basically now the present position, which it should be like 512 because we just told it to go to neutral position here, and then the current joint offset. So initially it will be 0, and then after that we minus 10 on it every time. So it's going to be 0, minus 10, minus 20, minus 30, and that's on. Also print out address 40, which is the present load, so-called present load. Okay, and then adjustment by minus 10, and then whatever the adjustment is, set it to the joint offset of the ID20. So remember, the endless loop here is to trigger motion index 3, which is a neutral pose. Okay, so it's trying to do neutral pose all the time. That's all it does. But the adjustment, the joint offset, was going 0 and then go minus 10, minus 20, and you see what is the effect on the grip itself. Okay, we're ready to do that. So this is COM3 code. Let's download. You download OK. Let's see the program here. Okay, and we'll switch to play mode. And then just run the program. Okay, go down, go to neutral, and then all it does is trying to play the neutral page. But you see it's keep on opening up. You see the joint offset starts 0 and then go minus 10, minus 20, minus 30. So instead of going to 512 as supposed to do when joint offset is 0, you can see it actually went to 503 because 512 minus 10 is roughly 503. And then minus 10 again become 493, 44. So you see it drop off by 10 each time. But let me stop the program, so it's very important. But the thing you see, the joint offset have a maximum of 255. You see it go minus 240, 250. Suppose the next time go 260, but it cannot go more than minus 255. It can also go no more than plus 255 if you want to go the other way. All right, so let's try it again. I'm going to run it again. And you see it this time. Close, neutral, and then all it does is say, oh, just stay at neutral. But they keep on opening up. You can see. Minus 20. So you see that? 412 plus 100 is 512. So this is an interesting trick, is you tell to maintain a certain position, but adjusting. Later, when we use the humanoid sensor, we use sensor to sense how disturbed it is and adjust it so that it can maintain balance. So that's in another chapter.